Assalamualaikum. We will continue our lecture on earth retaining structure for BQS552. So, in terms of classifying the earth retaining structure, there are numerous ways. So, I'm going to stick with this. Okay. First of all, we have what known as the gravity walls. Okay, so these are the walls that uses its own mass, its own weight to stop the earth from moving. Okay, we have the mass gravity wall. Okay, concrete gravity, Gabion wall, creep wall, and such. And then we have the semi-mass, and then we have the reinforced. Normally it's a reinforced gravity wall lah. Okay, and then we have the cantilever walls. These are the walls that uses its design, okay, to overcome the forces of the soil behind it. Okay, somebody just came in. All right, and then we have under these cantilever walls are concrete cantilever walls, counterfort, buttress, and precast concrete reinforced masonry. So that is the second type. Number 3 is the anchored walls. We have soil nailing retaining wall and reinforced earth retaining wall. So these are the walls that uses anchors, okay, for its stability. And then we have the piling walls. Okay, these are the walls that are being made with piling method. We have contiguous ball pipe wall, diaphragm wall, sheet pile wall, and many other types of piling methods. And finally, number 5, we have the hybrid wall. So normally this is a combination or special type of retaining wall. Okay, tie-back anchor wall, anchored earth, tail gabion, and tail concrete block. So this is a combination of types of retaining wall, and then they call it a hybrid wall. Okay, so first of all, the gravity walls. Okay, so as I said, the gravity walls rely on their significant mass and geometrical dimensions for stability against the failures that I mentioned in previous class, sliding, overturning, and whatnot. So little or no contribution to the stability is made from the passive resistance of any soil acting on the face of the wall. So it has resistance, okay, passive earth resistance, which is over here. Okay, so this force of passive resistance is very small because of the design of a gravity wall itself. It does not have any elaborate design on the toe of the retaining wall. Okay, so normally it would rely more upon this sliding resistance, okay, between the wall itself and the ground beneath it. Okay, so okay, so there are 3 types of this retaining wall. We have mass construction, semi-mass construction, and reinforced construction. So this is the mass retaining wall construction. So it purely is using its weight to withhold the soil behind it. So you can use a lot of material for this, okay, as long as it has the weight. Okay, so mass construction can be broken down to three types. Okay, so the mass construction can be further broken to three types. We have concrete gravity retaining walls, gabion walls, and creep walls. Okay, just checking. All right, so concrete gravity retaining wall, it uses, in this case, plain concrete or stone masonry. It's just that if you use stone as a main material for retaining wall, you can't really build it that high. Okay, and the mass concrete wall itself cannot be built very high, up to three meters only, and then the cross section shape of the wall is affected by stability. Okay, the use of space in front of the wall and required wall appearance and method of construction. Okay, so normally the cross section or the design of this concrete gravity retaining wall is very simple. Okay. Next, we have gabion walls. Okay, so these are like we have a metal cage which are being filled with stone or rubbles, and then we use it a lot to what you call block the soil from falling or crumbling down. Normally being used as a temporary retaining wall. Okay, so these are free draining walls constructed by filling large baskets with broken stone. So what does it mean by free draining? Okay, so these walls does not require any type of dewatering holes, or what they call it as whip holes, because as we know, as when rain happens, it will, some of it will drop behind the retaining wall, okay, onto the soil behind the retaining wall, and will start to gather behind the retaining wall. So if there are no whip holes, this can spell disaster, as the active earth pressure behind the retaining wall will increase. So the weight of the soil behind it plus the pressure from the rainwater. Okay, so normally for retaining walls, they would have a lot of these whip holes. But since this is a gabion wall and it only has crushed stone inside the basket, so there's a lot of gaps between the stones, so water can pass through it. So we do not need these whip holes. So retention is achieved from a combination of the stone weight and its interlocking and frictional strength. Okay, so the stone that's being put in this basket are very heavy. So even though the basket itself is not that heavy, okay, so that's why it is a gravity wall. Then the wall face is better approximately 6 degrees from the vertical, okay. And maximum height 10 meters, okay. So either step face or a step back with certain angles lah, okay. So the basket itself is made out of nylon, polypropylene, okay, or polyethylene grades. But the one that we usually see here in Malaysia, they are from metal wires, okay. Hexagonal twisted steel wire mesh. So these are the one that's being used here. hexagonal twisted steel wire mesh. So again, this is another example of a gabion wall. This is very properly stacked stones inside the cage. And they even prepare a weep hole, okay, to further speed up the process of water being ejected from behind the gabion walls. So it doesn't really need it, but to speed it up, we can have these weep holes being installed. Okay, so an example of gabion wall. These gabion walls seems to be already a permanent feature of this landscape because we already have plants growing into the gabion wall. So that's another advantage of gabion wall. It allows plants or small plants with roots to grow on it. Okay. So this will further strengthen the gabion wall itself. Okay. And also gabion wall can be used can be used underwater. You can see here. Okay, so this is the normal water level. So we put the gabion down here, and it's not a big issue. It will still retain the wall under the water level. But there are some preparation that you need to do. We have the mattress, for protecting the surface here. And then we have the geotextile here, being installed behind the gabion wall. Acts as a filtration system. This is an example of a crib retaining wall. So it uses these concrete cribs to create a grate. Okay, so it is also what you call, it doesn't require this weep holes, because you see there's a large opening between these concrete cribs. Okay, so known as bin walls. So they are constructed by interlocking individual boxes made from timber, precast concrete, or metal members. I'm not sure. They don't have the okay. It might look as a box, but it's not. The one box comes as a whole. It is usually from section of crib, concrete crib. It's like this. So you have this top part of the crib, and then we have the separation here. That is another component of concrete. So it's being stacked one against the other. Okay, so it does not come as a box on itself. And then, so by putting this what you call crib, concrete cribs, one against the other, we are creating a three-dimensional grid, a three-dimensional box. Okay, it's like we are creating a skeleton of the retaining walls. So we need to fill up this skeleton of a wall with materials. So normally they will be, after the what you call the skeleton of the crib wall has been completed, it will be filled with materials. Okay, so either with crushed stone or other coarse granular materials. Okay, normally granular materials lah, stone type of material. So once we have put in this crib with all these materials, okay, so it becomes what you call, it becomes a wall on itself lah. So it works something like the gabion wall. It's just that the gabion wall use this what you call steel wire boxes, and steel wire boxes. Crib retaining wall uses that skeleton crib, the skeleton, or what you call it, the concrete crib, to hold the material inside it. So the material normally granular material. So because if it's just the concrete crib skeleton, it does not have the mass to withstand the pressure from the soil behind it. It does not have that weight. So it needs to be filled up with granular materials. Remember to create a free draining structure. As you can see, there's a lot of holes here. Okay, so it doesn't really require any type of weep holes, and it can even allow for vegetation to grow around it. This will further strengthen the crib wall. Okay, so you can see there. So this is a cross section of the crib wall. First of all, they will build the base at an angle, a ratio 4:1, or whatever the engineer decides. And then they will start to stack up this concrete crib, okay, to stack, arrange it in an orderly fashion, one by one, until it reaches its top where it is fastened. Okay, it will not move anymore. And then inside of this crib skeleton, they will be filling it with material. Here they use 75 mm crushed gravel. Okay, so they have to make sure that the material does fully cover the entire inside area of the skeleton crib. Okay, the crib skeleton. Okay. So that is for mass construction. For semi-mass construction, we put in other elements such as reinforcement into the walls. Okay, so you can see here we have reinforcement here to further strengthen that mass retaining wall. Okay, so it's a compromise between simplicity of mass concrete and low material content of reinforced concrete. Can be cost effective if the details are simple. Okay, so this is this is an example. Reinforced construction. So it is using the mass of the concrete as well as the strength of the reinforcement. So we have here reinforced construction. So it's a special type of gravity wall. Stabilizing weight may be supplied by the weight of the restrained material resting at the base slab. So pressure can be reduced by widening the base slab at the back or front of the wall. The types are concrete cantilever, counterfort, buttress, precast concrete, and reinforced masonry. Okay, so we are done with semi-mass. This is reinforced construction. Okay. So, all right. Number 2. they did not provide the detail of this reinforced construction, especially the concrete cantilever counterfort buttress. So I suggest you check out the literatures or videos on this type of walls. Number two, we have concrete cantilever retaining wall itself. Is this the example? Yeah, it is the example. Sorry about that. The way they title this slide is quite confusing. Okay. So first of all, the concrete cantilever retaining wall. So this type of retaining wall is being made out of concrete and reinforcement. Okay. Cantilever wall or stem wall of reinforced concrete are the common type of gravity wall, composed of vertical or inclined slab monolithic with a slab base. So again, a vertical with a base. So it is simple form. Cantilever wall utilize the weight of the earth or backfill on the hill, as I said earlier. Okay, you can see the hill here is very large. The purpose is that so that we have a volume of soil pushing down against this hill, acting as a part of the wall itself. Okay, so it will push down on this hill, planting this retaining wall further into the ground. Okay. This weight is added to the concrete weight to provide resistance against active thrust or active earth pressure. So we do not need to use as much concrete as we have to. I mean, if we don't have this here, we have to make this vertical wall a lot thicker to have that mass. But since we have elongated this hill and all this soil is on top of it, so this soil act as a vertical wall also, pushing down on the hill. Simple to construct and permanent joint are easily arranged. Of course, we need jointing because this is a concrete construction. Okay. So another example, if you need to draw, you can draw it like this, a very simple two-dimensional drawing. We have the wall, and then we have the concrete base. Here we have the elongated heel. On top of the elongated heel, we have a lot of material or soil. Another feature of this type of wall is that the reinforcement is always at the back or the surface that are facing the retained soil. So the reinforcement is actually here. Oh, sorry. It's at, I'm not really sure you can see my pointer, but I hope you can figure out the location. Next is the counterfort or buttressed wall. Okay, I'm gonna try something else just to ensure that my pointer is showing. It's not really showing that well. All right, so we'll try that. Counterfort walls are cantilever walls strengthened with counterfort. So what they mean by counterfort? It is this triangle thing. Yeah. It's not even showing. Okay. So this triangle thing. Okay. So this counterfort will further strengthen the wall itself. Okay. So you can see here, this is the triangle counterfort. Okay. Um, so it is the wall itself is strengthened with counterfort or the triangle thing, okay, monolithic at the back of the wall slab and base slab. So it has another component to it, which is we have the wall, we have the base, and then we have the counterfort. So they act as tension stiffeners and connect the wall slab to the base slab, reducing the bending and shearing stress. So by having this counterfort, we are reducing the stress between the wall and the base. Okay. The height, okay, is between 8 to 12 meters. Okay, so this is another example. Okay. Usually the counterfort is at the back of the wall, but sometimes it can be at the front. Such as this one, you can see the triangle counterfort is at the front. This is what? This is a masonry buttress retaining wall. It uses bricks. Okay, very hard to find these days. This is a precast concrete retaining wall. What you call it? Okay, a totally precast concrete. So precast concrete retaining walls manufactured from a high-grade precast concrete. So it needs to be high-grade, okay, so that the material, the what you call retaining wall, does not fail under extreme earth pressure. So it uses a cantilever principle, usually comes in modules. So it has a 600 mm wide module. So this one is a bit larger. I'm not sure if this is 600 mm. Okay, but you get the idea. It comes in modules, so we can attach one beside the other. Okay. So it can be erected on foundation as permanent retaining wall or freestanding as a dividing wall of heat material. It can be used as a permanent feature. If it's a permanent feature, then it needs a base, a concrete base, where we can tie this concrete retaining wall to the base. Usually they would use like bolts and nuts, okay? Or if it's a temporary feature, so it's just freestanding on the ground there, like this, okay? And due to its mobility, it is a precast concrete, we can arrange them in a square type or a circular type, and then can be used to store materials in it. Okay. So the units are reinforced on both faces to meet all form of stem loading. So the reinforcement arrangement on this concrete retaining wall is elaborate, meaning that it has reinforcement at the back of the face of the wall and also reinforcement at the front face. Okay, so this is the example. So you can see this is being bolted to the concrete foundation. So most likely this is a permanent feature. Okay, so this one, yes, it is a 600 mm module. So we can arrange it one next to the other. So this is the process of installation. So since this is a precast concrete, needs to be lifted into place. So it has all these like lifting holes. Okay, so we can use crane to lift it. Okay, over here you can see. Next, the reinforced masonry retaining wall. Okay, you can see the example here. So we are using steel reinforcement in the bricks retaining wall to resist tensile force and prevent the effect of shear. Brick bonding known as a Quetta bond used to create a uniform distribution of vertical voids. Of course, it uses like a block. This is not like common brick, it is a concrete block. So it is, they prepare a concrete base and then they have this starter bar going up. It's just like building a concrete column, I guess, or concrete retaining concrete wall. So they will have this starter reinforcement. So they would stack these concrete blocks one against the other, and also they will extend the steel reinforcement, making sure it follows the height of the block work. And then they will fill up the void with in situ concrete. So this will be a solid wall. So vertical reinforcement is tied on to the foundation reinforcement and spaced to coincide with the purpose-made void. When the brickwork is completed, the voids are filled with concrete. Okay, so there is a reinforced masonry retaining wall. Now, finally, we are moving into anchored walls. So what we have been talking about is, let's see. Okay, we have talked about cantilever walls. Okay, we have done gravity. We have just done cantilever. Now we are moving to anchored walls and then piling walls and then hybrid. Okay, so anchor wall, you can see this wall we usually will have this protrusion. Okay, protrusion here. Okay. So this anchor are used integral part of the design of a structure. Okay, an alternative to the use of reinforced concrete or other solution on grounds of economy. Okay, so these anchor walls compared to other types of wall are a lot cheaper. Act as temporary works, so can also be used as a temporary retaining wall and as a remedial or improvement works, improving the wall itself. So this category covers walls which use soil reinforced with reinforcing elements to provide stable earth retaining system. So anchor wall include soil nailing retaining wall and reinforced earth retaining wall. So soil nailing retaining wall is a stabilization method of reinforcing existing soil by installing threaded steel bar into slope or cuts as wall construction proceed from top down. So these steel bars are known as the ground anchors. If you have, yeah, so this is the example there. Okay. So grouted bars are installed to create a stable mass of earth. first step in building a solid wall. So first of all, they have to put in the grouted bars. And then for the nailing process creates a single block of earth able to hold back its overburden. So the soil nailing is an economical means of creating shoring system and retaining wall. Often nailing is less disruptive than other means of constructing retaining system. Yeah, by using soil retaining wall, um, we are not disturbing a lot in terms of the area of construction, because sometimes normally we will have retaining walls in crowded areas, okay, in towns. So if the area is already populated, full with people and stuff, it is not that easy to build a fully fledged concrete retaining wall or a mass retaining wall. We need a lot of access for that. So if it's the area is highly packed, there's not much access, and the requirement of earth retaining is medium to minimal, then this soil nailing technique would suffice. Okay. So working from the top downward, a mass of reinforced soil is gradually built up. In order to keep the soil from caving, in between the bars, some sort of facing needs to be installed. So we have the saw nail, but also we need to put the facing. So normally the facing is made out of shotcrete reinforced with wire mesh. So once they have put in all the saw nails, they will put wire mesh, and then they will just shotcrete everything. This facing can be vertical, better to a wide variety of angle, or made up of series of benches. So you can use this if you have a vertical face or in an angle, or is staggered in benches. Okay. So these passive bars are often referred as nail, and the soil reinforcing technique known as soil nailing. Nails, sometimes ground anchor is the same. Okay. So you can see here they are already starting to nail the soil to make it a lot stronger. Okay, so this is the machine that's being used to drill a hole into the ground so that they can put in the soil nail. Okay. You can see here, this is the framework. It's just a framework. It's not permanent part of the wall itself. It's just a framework so that they can put the machine to start drilling at the soil. So once they prepare that hole, they will put in the soil nail, okay, and start to pump in the grout. Okay, the process of drilling. Okay, you can see there's a lot of them here. So you can see there's not much area to work on with. So it is not possible to build like one large mass retaining wall over here, because you will obviously disturb the neighborhood. Okay, there will be a lot of trucks coming in and out, and the construction process would take a very long time. So this is a good solution to further reinforce this slope without disturbing the neighborhood as much. Okay. So this is when it has been completed. They have already put in the nails, and then they have used a shotcrete to create a face for that retaining wall system. And you can see here there's a lot of of these weep holes, because we do not want water to gather behind the retaining wall. So this is the cross section of the soil nailing retaining wall. So this is the nail itself being grouted and all, and then they will build the face of the retaining wall. Okay, so this is the soil nailing nut or the ground anchor. Okay. This is the process. So they would excavate a small cut to create a face, and they will start putting the geocomposite strip drain, then start drilling to put in the nail bar. Once they have tied up the nail bar, they will pump in the grout. Okay. All right, so place temporary facing, and then they will start to build the face of the retaining wall. They cannot just leave the soil exposed just like that, even though they have already put in the nails. So they have to cover it, normally by the use of shotcrete. Okay. So this is the construction of multiple level of soil nailing retaining wall. Okay. So they have their layers of facing for the wall. So no, most probably the shotcrete is just a temporary, and then they will have a final facing, so they can put a layer of finishing materials to make it more presentable. Okay. Next is the reinforced earth walls. Okay, so normally we see this or when there's a sky, what you call, sorry, we have a flyover. So known as mechanical stabilized earth wall or earth walls. They are structures which have been made using steel or geosynthetic soil reinforcement, which are placed in layers within a controlled granular field. Okay, so it's something like this. Okay. Combination of reinforcement and earth create a composite structure which is internally stable as long as sufficient reinforcements are placed within the earth to counteract the shear forces that result when soil is placed 90 degrees. Okay. So what is keeping the wall on its place is these reinforcements. Okay. See the reinforcement. So these reinforcements, okay, when we put filling at behind this, okay, so the reinforcement will be what you call held by the filling. So we need a lot of reinforcement. So the granular fill will be all over this reinforcement. It will hold the reinforcement in place, and that reinforcement will hold the wall in its place. Okay. So it consists of soil, steel strip, soil reinforcement, and precast concrete panel. So we have the precast concrete panel, okay, this panel. And this panel is connected to a metal strip, which acts as its reinforcement, okay. And then behind, within that soil reinforcement and beyond, we have the filling material. Other system utilizing different facing system, wire and masonry blocks with different soil reinforcement type, welded by mesh. Okay, so there are other alternative to the basic system lah, okay, which is this one. So another example, you can see that the reinforcements, okay, it is attached to the face of the retaining wall, and it goes very deep into the soil. So this area will be filled up with material, whether soil or granular materials or whatever. So it will hold these reinforcements in its place. So that reinforcement will hold this wall in its place. Okay, another example here. Okay, so this is what we commonly see at the reinforced earth walls. A good advantage of using this system is that you do not need to drill holes into the ground to install these reinforcements. It's already there. It's just that, let's say, you have to drill this area, sorry, you have to dig up the soil in this area and then uh, arrange the panels with the reinforcement in its place, and then fill this void with granular material. So it will hold the reinforcement in its place. So if we are using the previous method, we have to drill through the soil. Okay. So the difference between soil nailing retaining wall and reinforced earth wall. Okay, soil nail retaining wall have to build downward with the soil being reinforced in situ. Okay, you have to drill it from the bottom up. Very noisy, okay, very messy. While a reinforced earth wall is constructed by building an embankment, which is strengthened as the work progresses. So as you are stacking the panels one over the other, obviously, you will also arrange this reinforcement and then do the filling level by level. So a reinforced earthwork is constructed by building an embankment and then strengthened as the work progresses, constitute as the difference. But in terms of design, almost similar. Okay, so yeah. Next, the pile retaining wall. So we are using piling as retaining wall. The contiguous bore pile we use, as the name suggests, bore pile. Okay, so we are using boring concrete pile adjacent to each other. Okay, so this is a bore pile. Kan? See, it's being arranged one next to the other, and when we dig up this area inside here, it becomes a wall on itself. Piles are brought into depth, which is sufficient to counter the force which tries to push over the wall. It is employed both temporary and permanent. Power over higher stiffness retaining elements which are able to hold lateral pressure in large excavation depths with almost no disturbance to the surrounding structure. So that's why the contiguous bore pile wall is popular for the construction of basements. Because it is very, very strong, okay, compared to other means. Okay, another example of contiguous bore pile. Okay, so this retaining wall is super solid. It is super strong. Okay, it won't budge. Okay. Next is sheet pile. So the use of sheet pile wall are constructed by driving sheet pile steel sheet into a slope or excavation. So you just usually just drive it in or vibrate it into the soil. So normally being used for temporary deep excavation. So normally we use sheet pile as a temporary retaining wall. So it considered to be most economical where retention of higher earth pressure of soft soil is required. Yes. When you want to retain soft soil such as sandy soil or clay soil, it's best to use this sheet pile because it has an interlocking mechanism between the sheet pile itself. Okay, so this is sheet pile retaining wall. This is a permanent feature. Okay, obviously, it needs to be maintained. It needs to be painted or something to prevent it from rusting. Okay, they even include this ground anchor to further strengthen this retaining wall. So the shapes of sheet pile, as you can see, all of them have this bend so that it can interlock with each other. Okay, so the interlocks, okay, many types of interlocks. Okay, the last type is the hybrid system. So hybrid system, anyone which uses facing unit or any type to rods or strip of any material would have their ends anchored to the ground is a hybrid wall. So it is a combination of elements of both externally stabilized walls and internally stabilized walls. So it combines both. Okay? So tie-back anchor wall, anchored earth, tail gabion, and tail concrete block. So let's look at the first one, the tie-back anchor wall or anchor earth. So this is the example. Okay. Tie-back or tie-down can be installed virtually any ground condition using rotary, percussion, or down-the-hole hammer tooling. Or these other tiebacks. Okay. Like the ground anchor. Okay. The critical design elements are the capacity, length of unbonded zone, corrosion protection, grout cover, and testing. Construction of tieback bars or cables are placed in pre-drill holes with concrete grout, same like before. Cable accommodates high-strength pre-stressed steel tendon to protect the tie rod from corrosion is coated or paint. Okay. So we have some sort of concrete wall here being built together with this tieback. So this is a hybrid system. So we have the retaining wall. Since I'm seeing it, the retaining wall is going down all the way down here. So maybe this is a piling type of a retaining wall. So to further strengthen this pile retaining wall, they use a tieback anchor or the ground anchor. So this will further strengthen this wall. Okay, another diagram you can see. This is soldier pile or wood legging. This is a old type of retaining wall. Then they use tieback to further strengthen this retaining wall, and then they put in the finishing. This is not required, just to make things look a bit better. And then the second type is the tail gabions. Okay, you can see here. Gabion element fitted to geogrid tail extending into the supported soil. The structure recognition was built in 1979. Okay. So the vertical skin of gabion can be anchored to the backfill using metal strips. So it is something like the previous one that the reinforced earth walls, but we are not using concrete panels, but instead we are using gabions. Okay, so that's why it's a hybrid system. Okay, rojak already lah. Okay, so to aid anchorage, the ends of the strip are formed into the shape designed to bind the strip at the point of the soil. So you can see that these are the gabions. Normally, it will just be stacked at this slope here, stacked directly at the slope. But this time, they move the gabion forward, and then they have like mesh reinforcement being extended from the gabion into this area. So when they put in the soil back, they fill up this area, okay, level by level, of course. So this soil will hold to the mesh reinforcement, which will hold the gabion on its position. So the gabion will not move. So that's a tail gabion. Tail concrete blocks, I'm sure it's somewhat similar. Okay. Concrete block facing unit fitted with geogrid tail. So it has some sort of a tail, similar like this. In this case, they are using mesh reinforcement. In this case, they are using geogrid as the tail. The vertical skin of gabion can also be anchored to the backfill using metal strip. To aid anchorage, the end of the strip are formed to a shape. So again, you can see that this is the concrete block. Being built into it are these, what they call it as a geogrid. So this is at the back of the wall actually. So this geogrid has been built into this concrete block. So when they put it, the geogrid will be extended all the way as a tail. And then when they fill up that area with granular material, you can see this is the filling material. This granular material will hold that geogrid in its place. That geogrid will further hold this concrete block in its place. Okay, same principle. Only with different materials as the tail and as the retaining wall. Okay.